Hello, everyone, and welcome to my Lead Up 2022 talk, The Art of Creating Security Challenges. My name is Sebastian Stohr. You might know me as Superhero1 from Twitter, Twitch, and YouTube. I'm excited that you're joining me for this awesome topic. You might have played the CTF this time or other CTFs before, so this might be interesting for you. And I want to start with the question, well, what is it about creating security challenges? We could compare it to baking a cake. Well, there are different ingredients. There is a recipe, there is tools required, and then some knowledge and skills. Similar to creating security challenges and creating challenges for CTFs or hacking platforms like Hack the Box, Try Hack Me, and others. So there are some ingredients that is probably program code. There are some tools that we would need that are probably compilers. And there are some skills, maybe about vulnerabilities, how the inner works of a CPU, memory, and all that stuff works together. So this will be content of this talk, and we will start with a little bit of more information about myself. At Day, I'm a senior solution architect, which means I design software applications, how applications work together, what components are used in a project, what are the pros and the cons. So this is quite exciting already, but even more exciting is what I do at night. I'm a hacker, I'm a content creator, and I'm a speaker. Because I enjoy sharing the knowledge that I acquire in my free time, looking at different kind of technology and, well, the latest stuff that just pops up on the internet. When it comes to certifications, I have the OSCP and the Pentest Plus. Basically, I took both of these out of curiosity. I just wanted to know, do I have the skills after a certain time of playing CTFs, after a certain time of hacking machines on some of the platforms that I mentioned previously. And yes, OCP and LinPs made me kind of famous. So in case you saw my tweet, yeah, that's right, I am the one. I also play CTFs myself just because I enjoy the riddles and I like to put my knowledge to the test. And Packet Warriors in 2020 was a really awesome and fun experience. I did both the solo and the team CTF. One of them was an attack and defense style, so not a Jeopardy style as we had this time at the lead up. And I also participated twice with a random team, people from my Discord, people I just met online on the Red Team Village CTF that is happening during DEF CON. And we made it to the finals twice, and last time we even got 10th place, I guess. So that's really cool, and I enjoy working and collaborating with you guys. I'm a seasonal bug bounty hunter, which just means I don't have the time always to go after bug bounty hunting. But well, that's one part, feeding my curiosity, and then bug bounty hunting has to take a little bit of a backseat for me. I'm a member of the Käferjäger and the BDE squad, so in case you meet any one of them, say hi, and they always will have a good time. What is this talk about exactly? Well, what goes on behind the scenes? We are not actually making a cake. We are looking at challenges, we are looking at code. I give you some examples. I give you like high level how-tos, what you can do to make some progress in that area and get familiar with some of the techniques that are required and skills you can build up to be a successful CTF challenge creator or a machine or room creator. So where do we start and where do we go next? We will touch on this briefly and let's see how far we can go. In general, if we look at the whole IT landscape that is present in these CTF challenges, we have usually good amount of web exploitation challenges just because it is an area where a lot of people are familiar. So you can practice a lot looking at WebSec Academy that basically has a lot of the vulnerabilities that you can find in these challenges too, which could be local file inclusion, XSS, or SQL injection, and a lot more. So this is definitely worth to check out on a regular basis just to polish your skills. Sometimes there are also labs added. So this is a really good example of training for web exploitation challenges and also get ideas about how challenges could look like. Cryptography, on the other hand, is a little bit more depending on experience and knowledge. So I feel people who had that as part of their study program, they will have a little bit of a lighter way to deal with these challenges. And people, for example, myself, that did not come across a lot of cryptography in their education with university and so on, I think we will kind of have a hard time understanding the concepts if they get more complex. If this is not a standard implementation, then it is quite difficult. And you need to spend a lot of time looking at write-ups is always a good option. So in case you are targeting a specific type of challenge, you could go on ctftime.org and just look at recent CTFs, at recent challenges, look for write-ups, try to understand or maybe even reproduce these. So you will gain more skills by looking at examples. Pawn and binary exploitation is basically my favorite category. That is why I also created 2 challenges for this CTF in the binary exploitation category. I find it quite amazing that you can modify or alter the way a program is executed based on weaknesses in the memory layout, some functions, and you kind of inject assembly code and then you get a shell and you access the remote system. This is so fascinating to me. It was literally difficult to start with. I know there are some great resources on YouTube that you can watch, like Live Overflows, Binary Exploitation series, and then there are also quite some other streamers that do regularly some challenges, even from some of the hacking platforms like Hack the Box. And I feel you need to understand the basic concepts of what is actually happening in this category. So a little bit of knowledge about the memory layout. Later, if you want to address heap vulnerabilities and how things are addressed, how pointers work. And the more you learn about this, the easier it will become. And then to basically understand the 5 most common challenge types, I think you can do this in a couple of weeks with the right examples and also hear write-ups and maybe even collaborating with others that help you understand how these things work is really useful. Forensics is usually really fun because I feel like you can just find a way forward. Usually Wireshark is involved, look at some packet traces from USB, from HTTP, or some other data stream, which is really cool. And then there are already some tools out there and you can Google how to make a progress. Maybe there's a Python script and you can adapt it a little bit. So that is an awesome category as well. Reverse engineering is very heavy on assembly usually, so you have to find your way around Ghidra and IDA Pro or IDA Free. It depends on how big your budget is. I work with Ghidra mainly. It is mixed. So Also, a lot of experience required, I would say, and some affinity to this kind of language and the way these challenges work. Also, there could be some mechanisms involved that are kind of basic, but if you have not heard about them, like what XOR operations are, bit shifts, and so on, it can be a little bit challenging. So scripting, for example, or programming is usually a very fun category where you just have to optimize some data parsing or any other cool ideas that basically allow you to access the relevant data, find the flag, or be very efficient with your code. So this is a little bit of a more detailed overview about the different categories. And I think every category requires a little bit of a different approach, a different skill set. That is why playing CTFs in a team is so much fun. And there can be also other categories like mobile. I did not put mobile here. It's kind of self-explanatory. And MISC is a category where I think, there's a potential for some great challenges that just do not fit in another area. Let's continue. Player versus creator. We talked a lot about playing CTFs, but actually we want to know what is the difference now between the player and the creator, and I want to explain this to you with an example. So what skill needs a player? Looking at a buffer overflow. So you download the challenge, you run it on your local machine, and you realize, okay, there is actually buffer overflow. Sometimes it is very obvious, but in other examples, it can be that the buffer overflow is a little bit hidden, and you have maybe to meet certain conditions as well, depending on the level of difficulty of the challenge. So you might want to load it into Ghidra to look at the assembly code, look at the functions in the debugger, and exactly, debugger. You could also load it in GDB or some other tools depending on the platform. But let's keep it simple for now. So you confirm the vulnerability by just hammering a huge string into some input field, and then boom, there's a seg fault, and you're like, yikes, this is my buffer overflow. Okay. We could say you basically don't need a lot of knowledge if you now just create a cyclic pattern. So a pattern that is kind of unique for every 4 bytes and that does not repeat itself. There are already tools in Metasploit that can do this. So you just do pattern create and so apply the length, and it will give you a string that you can then paste in the challenge application's input. From there, you need to find the jump location, or for example, a wind function, or maybe if you can execute code on the stack, you have a little bit of a different way of doing that. We will look at an example in this talk very soon. And basically, once you identify the offset and you know where you want to jump to, you fill the stack with padding until the offset, so usually with A's, and then you add your payload and you win. So hopefully you get the flag, and hopefully you got the flag in my easy registered challenge. But what about a creator? What skill needs a creator? What is different? So basically the player, you could just learn that, adapt it, and repeat. You basically don't really need to understand how this buffer overflow works. It's just like, you do this every time. If it works good, you get the points, you get the flag, but if not, well, so what? A creator, though, needs to understand what is the reason for this vulnerability. Like, how does it actually work? So, a deep understanding of what a buffer overflow is. What is causing the buffer overflow? The seg fault. Well, So to say, it's a fixed size character array, and you use the gets function, which does not check for bounds, which means you have a fixed size of an array, let's say 40, and the gets function just reads as many characters as you put into it. So if you put anything bigger than 40, there is potentially a segfault because you're overwriting other areas in memory. Are there any other conditions that have to be met? Yes. In the recent versions of the compiler, I don't know about all the way back in the past, maybe there weren't these compiler flags, but today we need to supply compiler flags, especially if we want to disable some security mechanisms like executable stack, for example. If we pass shellcode with our input, it's put on the stack in memory allocated to this process of our binary that we are running. And if this has a security flag non-executable stack enabled, we could not run shellcode even if we would pass it as an input. So you can look it up with checksec, and it will display you different values for the different security protection mechanisms. And here for a buffer overflow, if we would want to pass shellcode, we would have an X to be disabled. What we could still do is, if we know a special function that we would jump to, well, that is just overriding the return pointer, the return instruction pointer, RIP, or EIP, depending on what kind of architecture you have. Which leads me to the next point. A little bit going over the libc version here, just because I think you would really have to keep track on like what changed in which libc versions, especially for heap exploits. It does not really work with every libc version, but there are also great repositories. I think How to Heap is one of those where you can read about it and have examples for each and every heap exploit concept that they have on their repository. But well, let's talk about operating systems. So obviously Windows acts a little bit of different compared to Linux-based operating systems. So an buffer overflow in OSCP, for example, so it's working a little bit different than a buffer overflow that we did in the CTF now, for example, with the easy register challenge. And then 32-bit and 64-bit have different ways to address memory or different length of addresses as well. And this is also something we have to keep in mind and something we have to consider when we create a challenge. And then, well, it's not mandatory, but it's just nice to give the challenge a story or a theme. Well, I mean, the challenge would also work if you would not supply any text, if it would just wait for input and then do whatever you want it to do. But I think since it's also kind of a competition or a game, it's nice if you add something around it. So if you saw the bird challenge, I actually call it Singing Bird. I'm not sure how it will be called in the CTF because I just don't know. I created a little bit of a theme around the bird, and the bird is singing. It can sing some format string vulnerability kind of addresses from the memory. And I just thought it's nice. And if you do not supply a proper password, the bird's not singing at all, the cage is empty. So yeah, I just wanted to create something with this challenge that is, yeah, in a way, attracting people to try it and to see how can I influence this program, what does change, in which way. So it's, I think, a little bit more attractive than just having a plain challenge, which basically can do the technical concepts, but yeah, does not have anything around it. And last but not least, you should always test, modify, adapt, and repeat what I just said, because it's very crucial that the challenge also meets certain quality criteria. So how does a challenge look like? This is part of this CTF, which is now over. And Easy Register actually had a fixed array of 80. We printed the address of the stack or of this input buffer here. And then we used the gets function to insecurely get the input that the user enters. And hopefully you made it and overrode the return instruction pointer and executed some shellcode. So to make this work, you also have to set the compiler flags to make the stack executable, what I explained before. And this is done by putting the -f stack protector and -z exec stack with gcc. You can put these in the makefile and don't have to worry about it anymore. So here is how a solution could look like. I just added this because I thought for the sake of completeness. So you connect to a target here with pawn tools. It basically wraps everything that you need in nice functions that you can reuse. Then you set the context of the binary in a very easy way. If you have the binary on your local machine, basically it does load the operating system and the architecture from this binary. And shellcode in assembly will be created for Linux here. I think if we load the context, maybe we could even omit the Linux here. And then, depending on the behavior of the program, we are getting the data until something of our interest comes up. And the listing is at a certain address that is leaked here. And we can get all the data until the address is displayed. And then we parse it as stack leak into this variable. And then we receive until the input is actually happening. So I indicated that by the symbol. And then we just need to calculate the padding. These are the A's. As I mentioned before, 80 is the size of our array. 8 is the address length of the base pointer, and then we subtract the length of the shellcode. So this is how we craft our payload, the shellcode plus the padding plus the stack leak address. So what the program will then do, we will fill the memory with our shellcode. Then we will fill it all the way up, even override the base pointer, and then we will override the return instruction pointer. I hope I didn't mix up anything with the base pointer here. If so, I'm sorry, but like this is the correct way of doing it. Fill up the array, put the shellcode there, fill up the array, override one more address until you reach the return instruction pointer. Then you send the payload and create an interactive session. And if you did that during the CTF, congratulations, you got some points. Now, let's think about from good to great. What makes a great challenge? I said there are some quality requirements, and I think I put the most important ones here. It should be stable and it should be reproducible. Like it should not only work once, it should actually work all the time. I mean, I admit when I tested my bird challenge, I had some trouble based on different environments, based on different operating systems. Sometimes it was a little bit messy, but actually the code was clean. So I tried again, I spun up some VPS, I tested it again, and repeated that process until I was sure that it worked as I wanted it to work. And another thing that I came across in one of the rooms on some of these hacking platforms is that was actually pretty funny. So someone did have a vulnerable get parameter in the HTTP URL, So you could provide a name there or something else. And if you actually put // password there, it would print Etsy password. But this is not an LFI, right? An LFI works differently. And I think the creator of that room did not really know. So he thought, well, I just want people to enter // Etsy password there. So if we do a challenge about a certain vulnerability, let's make sure that this is also technically correct. And well, I just literally love this whenever I see it, when something is made with love. So either it's a website or a challenge, I think people recognize if you put effort in it, if you put time into it, if you put the time into it to test it and retest it and adapt it and modify it. So it really becomes a great challenge. If it has a story, well, it's not mandatory, but it's just adding a little bit of extra to it and makes it a little bit nicer, a little bit more approachable, a little bit more attractive, interesting. I did a hacking study group a while ago, and we had a theme of all the challenges that was like, yes, you are a secret agent, you are a special agent, and your task is to exfiltrate this data. And I just did that because I had fun doing it myself, and I thought this is just a great way to engage with people even more. If you can do a series or a set of challenges and have a like incremental that you can build upon previous challenges, I think this is also very valuable. Which skills are useful in general? I think curiosity, how things work, intrinsic motivation. Do you really enjoy doing this? Like, even if you get nothing out of it, is this something you want to spend your time on? And well, if you're a technophile, I think that is kind of cool. If you enjoy technology, if you like the latest Web3 stuff and you want to dive deeper into these topics or anything, it definitely helps to get your head around some of the concepts and walk the extra mile that is definitely required from time to time. In general, what's in it for you? You have the chance of getting the full picture of a vulnerability, which I think is always great. Think about the pseudo exploit series by Life Overthrow, which is mind-blowing. But also the time he invested into learning the concepts or gaining even more understanding of concepts he already knew, and then putting it into a format to explain to others and making videos about it. Like, this is a huge learning curve. So you can also then demonstrate a deep understanding of a topic, which in every application process, in every job you're going to do, if this is something related to this field, somehow technology, how you solve problems, how you approach a problem statement, I think this is really tremendous. And train to think like a creator will actually also help you to become a better player. For bug bounty hunting, this applies as well, by the way, because if you're training your brain to think like a developer, you can also think about things that could go wrong, things that could have been missed, like how do you escape strings, how do you make sure that there are no special characters in there, so on and so forth. And if you are actually knowing a little bit of more tricks around special characters and so on and so forth, just an example, you might find a way that the developer has not thought about. We are almost at the end of this talk, and I just want to say thank you that you listened to me, that you spent the time with the Lead Up Conference 2022, that you played the CTF, hopefully. If not, maybe you're a little bit more curious to play it next time. And thank you so much that you are part of this community. Thank you so much for spreading the word. If you like, please look at my channels in YouTube and Twitch and follow me on Twitter. And that's it. We're wrapping it up. The Art of Creating Security Challenges by Superhero. Goodbye.